Hey everybody, welcome to Wing Talk. Another great show today. This is going to be a great show today. We actually have a very special guest on here today. We're going to get into the technical aspects of everything you want to know about control links. But first, we got to say hello to some people. I will let you know right now. So all the chicks out there watching. Unfortunately, Luke is not on today. So you might want to tune out and wait for next month when it comes back. He will be back next month. But what we do have is our other heartthrob, Mr. Darren Lyons from the UK, also from the same part of the UK. Darren, how you doing?
Oh, yeah, I'm good. Well, at this point in time, I'm a few hundred miles away from Luke. He's gone up to Scotland. But yeah, usually we're in the same city. But yeah,
Yeah.
I'm doing pretty good. Yourself?
And oh yeah, doing fantastic. Sunday's my day off, so we don't mention the F word on on Sundays.
Of course,
And
that's a family-friendly show.
yes, so yeah, this is a fantastic show. This is um this show always seems to go together at the last possible minute. So yeah, it's always fun. I'm always interested to hear what we have to say. I'm always interested to hear what I have to say. So please tune in, keep watching. We're gonna keep going here. Mark Hoffman is with us. He's our pilot in charge. Mark, how you doing?
Yeah, hi Steve. I'm doing really well. Unfortunately, this year still not flown a single minute, mostly because of weather. But yeah, I hope that will start soon. Yeah, that's also a point. Nah, I mean that's at least my workday evening until we have finally our time, summer or winter time change, and I get some daylight after work. But yeah, looking forward for a nice show. And back to you.
Oh, thank you. Yeah, well, I did manage to get out and get an INAV flight in this morning. It was actually bitter cold. Well, cold for us. I think it's a summer vacation for you guys. But yeah, yesterday, most of the time I spend at flying fields, and I get to watch other people fly. And yesterday I was packing up, and all of a sudden, I mean, there was a really nice gas plane. I could hear it flying around, and all of a sudden the thing comes. I could hear it just coming straight down near me, and it hit the top of a metal roof and went right through the roof, penetrated right through it, and it was a beautiful Kyosho plane that just turned into splinters by the time it was done. I was yeah, that it sounded like a bomb went off, so kind of scary. But anyways, speaking of scary, the things that scare me are things like the FAA and the FCC here in the United States. We do have our own other versions of the FAA in other parts of the world. I wanted to address this just the start of the show so we can kind of talk about it a little bit before we get into today's guest. So we got a notice this morning, or I woke up to find out that a member of the group and longtime supporter, one of the main developers over at the LRS group, Wesley Vardy, is now under investigation from his version of the FAA for some of the flights. Darren, you have any information about this?
Only really what Mark posted. His video where he did 100 kilometers has been discovered by the CAA, which is the Australian equivalent. There seem to be a lot of CAAs, to be honest, but yeah, so theirs is called the CAA. And yeah, they're investigating Wesley, so he's pulled all his videos down. He said he's not flying any more long range stuff. But yeah, that's the gist of how I understand it. Yeah. Can't hear you, Steve. No, you're dead. More, yeah, technical issues on Wing Talk again. Can't hear Mark either.
Steve, yeah, I was muted, but Steve, we cannot hear you right now. You are completely muted.
I'm way better now?
Yeah, now it works.
Okay. So, Mark, do you have anything to add to this as far as the conversation about you hear what Darren said?
I mean, I don't know the exact facts, what happened and how it happened and how they get his attention or how he got their attention. I mean, the he posted a lot of videos, of course, with his long-range flights, and it was pretty clear that he was actually flying. And the regulations currently are, for our hobby, let's say, unfortunate, to keep it friendly. So yeah, we have to wait for an official statement of his side. I don't think that we will hear anything from the authorities itself. But yeah, I hope we get an update soon and see how that turns out.
Yeah, what I'll add to this is that Wesley is a guy that is one of the co-developers for ELRS. He's more of the front man, I would say, for the ELRS group. So he does a lot of the videos. And when you're a front man, you kind of have to carry the banner. The technical term for it is eat the dog food, and that's not to say ELRS is dog food. That's something that they use in the tech industry to say that you have to actually use your own product. And he, wanted to show by example that ELRS is a very serious contender for long range. And we're going to be talking about ELRS and all the other control links in a moment here. Just coincidental. We had nothing to do. The show topic today was picked out weeks ago. Nothing to do with what happened with Wesley. But it does bring into light that, when we talk about how far we can go with control links, at the same time, we have to keep in mind that there are laws and regulations. And when it came to our group in particular, a few years ago when the group was starting, there was a motion, something that was happening in the first, I'd say, 3 months, people started posting videos about how far they can fly. And they started posting about how high they can get. And I was really concerned about that in the group, because what happens is after about the fifth one, then other people will look at it and say, man, I can fly like this too. And if you live in some parts of the world where there's not a plane you'll see for a week at a time, then flying high is not really that big of a concern. But where I live in Southern California, if you go up over 1,000 feet, the possibility of you seeing something coming by is pretty likely to happen. So I wanted to make sure that, going out far is one thing, but going up high, getting to controlled airspace was something that I really wanted to avoid. So when people started posting, bragging about getting up to 6,000 feet, I was like, please take your post down or cut that out, because we do not need to promote that in the group. But at the same time, we're going to talk about things in a theoretical point of view. And the one thing that got me going, this is the reason why came up with this topic for today, was, if you are following the news here in the United States, let's just say the government's shooting down certain things that are up high. And I was wondering how likely would it be to get to up to 40,000 feet with a radio controlled plane? And then the other question I have was, when we're talking about range, it's very different to be standing on the shore of a beach or at the top of Mount Everest when you're talking about range. So I wanted to kind of get into the whole topic about range and what factors and what the radio links have to do with everything. So what I wanted to do is bring in one of what I consider to be one of the foremost experts on this whole topic, and that is Adam Maas. He is from Canada, and he's with us today. Hey, Adam, welcome to the show.
Oh, thanks for having me, Steve.
Oh, thanks. We talk all the
time.
time.
Rather glad to be here. Yeah, I know we do. This is the first time I've met Darren and Mark, although Darren, I regularly point people at the excellent video content you put up on your own channel.
Thank you.
Pleasure to meet you all.
Yeah, you too. I mean, we sort of chat a few on, well, not necessarily chat, but Adam's helped me out quite a few times on the not Discord, the GitHub for a certain firmware, shall we say. And yeah, it's great to have ideas backwards and forwards. And yeah, so thank you for that as well, Adam.
Yeah. Fantastic. So I wanted to kind of get into the history with you as far as control links. And I wanted to go back. We were discussing before the show the topic of, we're going back to control links now 50 years ago that were very popular. And that was AM and FM. So 72 megahertz here in the United States. And I think it's 38 megahertz in the UK.
Steve, your video froze. Is that only for me or also for the others?
No, it's frozen.
Yeah, I'm frozen. I'm all right. You can hear me.
Yeah.
I'm going to see if I can.
Yeah.
Wow.
In worst case, just drop off and on again quickly.
Okay.
Okay. Well, I'll take that from Steve and I'll give the quick start. So at least I'm quite familiar with the history here in Canada and the US, and it actually didn't start on 72 meg. We started on 27 megahertz, which folks might remember as the CB band. And a lot of toy stuff was on 27, even into the 80s and 90s. The problem with 27 is every time a trucker drove by the field, you got shut down because they were literally using the same band, and a lot of folks in the CB community were doing stuff that we see today in our communities where they're cranking up the power. They were taking that 500 watt CB or even 2-3 watt CB and turning it up to 10 or 20 watts so they could get more range. So that actually is why in the 70s there was a move to a dedicated band, which for North American users was 72 meg, interspersed with some other uses in that same band, but we had our own dedicated channels. 72 meg was great as long as you were the only person on the channel. It was a robust link. It was reasonably well ranged, beyond line of sight, although not to the level that we would consider long range today. But you had to be very careful because these old analog technologies had very limited ability to deal with interference. It couldn't have anybody else on the same channel at the same time. Very late in the day, some technologies were actually developed to at least not give control to the other radio if somebody came on your channel. You'd still potentially lose control, but the other guy wouldn't be flying your airplane. Which is why, there was a fellow down at Cypress Technologies, the chip manufacturer, who's led the development of a wireless USB chipsets, which were designed for relatively high data rate wireless printing like USB. So your keyboard, mouse, printer, all wireless. But what he figured was that at a lower data rate, sending less data, he could get much more range out of it. And he went to Horizon Hobbies and talked to them and eventually became their VP of technology. And that's where we got the first 2.4 gigahertz RC links. Or the original one was DSM Surface, which came out in 2004. Then we saw the original single channel, not frequency hopping DSM, and the various DSM-2, and then the current DSM-X were developments of that. Simultaneously, after that hit the market, folks figured out that there were other wireless chipsets that could be used, wireless USB chipsets that could be used in the same way. One of the most popular is the CC2500 series that we saw High-Tech use, we saw Grubner use, FreeSky used, even Futaba used it on their lower end stuff. And virtually all of the traditional 2.4 gig systems we use today are based on this wireless USB technology, adapted for line of sight use. The one exception is Futaba's Fast and Fastest systems, which came from Futaba is a major industrial controls company. Their primary business is not RC. That's a hobby for them because their owner's an RC pilot, and his father was an RC pilot as well. But so they're using their own in-house developed short-range industrial controls technology, again, for that longer range, that longer line of, but still line of sight use.
So that's pretty cool if you work for Futaba. So, yeah, but we've got all this cool stuff. I fly this for a hobby. I want to make something better for me. How cool is that?
Yeah, and that's really there's a surprising number of systems that originated that way. One of the classic competition radios in the U.S. Was in fact developed by an audio engineer. That was, I believe, it was called Proline. Back in the, don't quote me on that. That's the one I remember associated with them. But it was developed by a guy whose primary business and became famous for was working in Hollywood and developing audio technology for movies and theaters.
Hey everybody, I'm back. Did you miss me?
Hey, welcome back.
Thank you. That was, we've had guests on before that I couldn't drop out for more than 10 seconds because they have like one or two word answers. So great. I love that. Thank you for vamping for us. That was, you pretty much covered the whole thing with 72 megahertz. And one of the questions I had about 72 megahertz is there ever a possibility that this could be a long range protocol in the future?
And the answer to that is that we would need to work with the FCC to change the rules around the 72 megahertz band and how it's used. The chances of that happening are quite low. In fact, it's more likely that we'll see the 72 megahertz band taken away from RC entirely due to the lack of utilization in it and the use actually for short-range control links. Anybody in the U.S. is also aware that back in the day, if you've got a 40-year-old garage door opener, it was on 72 meg. It was not on our channels, but it was on the channels in between our channels. So if you're too close to residential services, somebody opened... There would always be a couple of channels at the field that you just did not want to be on because the next door neighbor's cheap garage door opener was on an adjacent channel and was maybe a little bit out of tune, and you might get away with flying a Cadet LT40 on that channel, but you wouldn't want to fly a Ferrari.
Yeah, I think the problem is also that the lower your frequency is, the bigger impact you would have in frequency up the line and down the line, especially for digital links where you need to send multiple packages in a very rapid order. So you need much more bandwidth relative to the whole frequency range. And the 72 megahertz band is very narrow. I think it's even tighter than the 868 in Europe or the 915 in the US.
It's much tighter. In terms of usable channels, so you're running 10 if I recall correctly, narrowband was 20 kilohertz back in the day. They used to have wideband, but that went out in North America in the early 90s. But so you're looking at 10 or 20 kilohertz channels, and you've got 18 or 20 of them. Whereas if you're running 10 kilohertz channels, even with wide channel spacing on 868 or 915, I'll pick 915 because I know that band better than I do 868. But 915, you're 902 to 928 megahertz. You've got 26 megahertz of bandwidth. 72, you've got less than half of a megahertz, less than 500 kilohertz of bandwidth.
And the next problem is, excuse my amateur-like explanation of that. I'm not an RF expert at all, but as far as I understand it, if you want to fight against interference and you want to safely distinguish the actual signal from any kind of noise around, especially if you're getting close to the noise floor, you want to have as many sine wave as possible for every bit you transmit. So if you have a very low frequency, you have to go extremely low with the bit rate to allow still a stable transmission. And I don't think that that's possible then to have a reliable link with like a 50 hertz or even more update rate at this frequency.
Yeah, or you're going to have to give something else up. Yeah. For example, you could do, say, a 4 to 6 channel link that's at 1024 resolution. That's quite reliable at ridiculously low data rates. That's actually how ELRS gets their incredible range at 50 hertz, is by minimizing the data you're sending to just enough to deliver the necessary precision. And then you can lower the data rate and still get the performance. That works great if you can get away with 4 to 6 channels. It also limits you heavily on what telemetry you can send back and how fast that can come back. It's not going to be really great for, say, GPS telemetry. It might be enough for voltage telemetry, where if you get a packet every 100 milliseconds or so, that's fine. But if you want to be able to track your GPS, your location accurately, you're going to need a little bit more speed, depending on, and it all depends on your use requirements.
By the way, we should rewind here a little bit and just ask you about your background, because obviously we're getting pretty technical with you, and you obviously have a technical background. Can you let us know what your background's in and what you kind of do for a living?
Okay, so my background is I'm an trained electronics technician and a electronics engineer. My area training is analog design, so radio frequency front ends. I've worked in IT for almost 30 years. It'll be 30 years this fall. And actually, right now, I manage an IT team for a moderately well-known IT company in North America. But I've got the ring, so this is a Canadian engineer thing. If you're a trained engineer in Canada, you wear an iron ring. So my background really is heavily focused on RF and as well as computing. I'm a lifelong involvement in the aviation business. My father is a 20,000-hour pilot. I grew up around it. I took my first flight before my first step. And in fact, a little story, if you ever go to the Air and Space Museum in Ottawa, Canada, you'll see the very, very first de Havilland Beaver, CF FHB. My dad's got 300 hours in that airframe. So wow. I grew up around this, both around the hobby and the technical side is something I've been doing for a very long time. Radios are a huge part of the hobby for me. Folks may know me as a Free Sky guy, but I've been heavily involved in the OpenTX and EdgeTX communities, as well as the Spectrum community. I'm reasonably well known, and actually I consider the Andy Coons, who writes the airware firmware for the DX and NX radios, to be a personal friend.
Awesome. Yeah, and then you also know a lot about ELRS as well.
Yep, and I'm an active ELRS user. It's not my primary link, but that I use. But I've got a couple aircraft on ELRS today. I've got 3 radios set up for it. It's a very interesting link, and I think it's a big part of the future of the hobby we're going to see, as is all of the LoRa protocols that we're seeing come into play.
Right. We'll get into the LoRa protocols in a couple minutes here. I just want to, that's great to hear about your background and so people understand when you're talking technical. And I guess the ring, you showed that to before. I was wondering what that was. If you're Canadian, the ring is electrical engineer. You get a ring to signify is a black ring. You're wearing a pinky. Is that what that's about?
So it's an engineering thing in general in Canada. Anybody who is trained as an engineer in Canada at an accredited school will go through, will get a ring at the end of the training. It's a stainless steel one now. I'm one of the last people in Canada actually who got the iron ring, the traditional iron ring. There's a long story about it with some very interesting crossovers, including to people like Rudyard Kipling, the famous poet. But essentially what happened is a little over 100 years ago in Canada, there was a bridge being built over the St. Lawrence River in eastern Canada in Quebec, and it collapsed due to an engineering failure. And due to that, additional regulation was brought in for the training of engineers in Canada. And as a reminder of that, every Canadian engineer who trained under the new rules was given an iron ring. The first bunch of those actually came from the scrap metal from that bridge, and it's a reminder every day to engineers in Canada that every design you touch has impacts, and your mistake, you have to take it seriously because mistakes can kill people.
Yeah, that's kind of cool. I like that. The Canada is our neighbors to the north of the United States, and even though it's easy to think, because when I go to Canada, it feels like when you go to your cousin's house and it's a different house, but it feels so similar and you feel so at home. That's how I feel about Canada. Even though you're a commonwealth of the monarchy, you are kind of, it's very similar to the United States, and we have a very close relationship with the Canadians as we do with the other parts of the world. I guess we're close because we're physically very close to each other. Anyway, what I wanted to get into now was we were started to talk about 2.4 gigahertz, and the original. The thing that I explain to people quite often is that the 2.4 gigahertz band, the transmitters and receivers from the original 2.4 gigahertz that you had from the 2007 to 2010 timeframe, have not gotten worse over the years. Physically, mechanically, they are pretty much the same. It's just that the band in general has gotten worse.
Yeah, I would, for a long, long time, there's all sorts of stuff on 2.4. Until the last couple of years, 2.4 was getting increasingly occupied. We're starting to see it free up a little bit with the move to 5 gig for Wi-Fi technology on your new laptops and such like that, and your Wi-Fi access points prefer 5 gig over 2.4, but it's still a pretty crowded band. There's a ton of bandwidth, but there's also a ton of users. And the other aspect is, as I mentioned earlier, our traditional 2.4 systems are based on technology that was designed to send a lot more data a lot quicker over a lot shorter ranges than what we use. The various 2.4 makers have done some amazing work to deliver line-of-sight performance from a hardware platform that was just never designed for it. And we've seen the arrival of hardware platforms that are designed for actual long-range usage, even at higher data rates than what we use. And the classic example of that is the Semtech chipsets we saw first arrive in 900 with Crossfire and then R9, and which, by the way, those systems were using LoRa-capable hardware, but were not necessarily LoRa themselves. They were already, but because the hardware was designed for actual long-range usage, we got way better performance. And now we're seeing that creep into 2.4. The first one out there was, of course, TBS Tracer, and we've seen the Immersion RC Ghost system. We've seen FlySky's AF-HDS3, ELRS, of course, and now FreeSky's got Twin. And there's another Chinese system called Siyu, if I recall correctly, SIYU, that's available. Although I haven't seen any real uptake on that system as of yet, beyond people using the hardware for ELRS.
So before we jump into the LoRa, by the way, LoRa is capital L, small o, capital R, small a, stands for long range. So when we say LoRa, it's not Laura like a girl's name, that's long range. I wanted to ask you that this is something that comes up quite a bit, and I know we've talked about before, is people are flying in the middle of nowhere. So they have these flying fields that are far from civilization, and they always talk about the Bermuda Triangle, where you go out to a certain point and then your plane goes down and crashes on traditional 2.4 gigahertz. And what we're starting to find is that there's things out there, agricultural things such as watersheds or maybe oil wells or something, where they transmit signals from one of the utilities to another. And if you happen to fly to that band, depending which kind of protocol you're using, your plane goes down.
Yeah. That is a real issue because 2.4 gigahertz is what's called an ISM band, which is industrial, scientific, and meteorological. If I recall correctly on the M, I know the IS
medical,
is industrial and science. Oh, medical, yes. Yeah. Thanks for the correction. There's a lot of other uses. One of those is for control links for everything from hydroelectric dams to microwave towers. They're not the actual data transmission, but they're the links back end that are used to control the equipment at these locations. One of my fields, by the way, has a Bermuda Triangle. It's a link between, and this is kind of funny, it's highway lights. It's honestly, we fly, we're not very far off from a major, what's called the 400 series highway here in Canada, in Ontario, which is, think of it as an interstate. It's the Ontario equivalent of an interstate, and the lights are all controlled. They're via a wireless link, and what it is it's a shaped beam 2.4 signal. So it's not very strong in and of itself, but it's a very high gain antenna with a very narrow band. And when you brush against that, it swamps you. It's just like if you put your most people have seen this. You put your transmitter down next to a receiver, you'll lose link with the receiver. It's called swamping because the signal's just too strong for the receiver to make anything out. And this, when you brush against these shaped beams, you're basically putting your receiver through an area where there is a huge amount of on-band or near-band noise, and it can't hear anything else. It's the same thing as
swamping. That's what that is. I was wondering about, because what you're talking about when you say shade band, the idea is that when you're talking about light in general, I remember this from the photography years, light goes out in a 360-degree pattern, so that when you double the amount of power, it's actually 25% more power by the time it gets to it, because it's going 360 degrees. When you take a reflector and you focus the light beams to one specific area, and in this example, they probably have maybe 5 or 6 different lights that are trying to control from one controller, and the beams are pointed directly at it with a very narrow band, maybe of about 2 degrees, 3 degrees, something like that. And if you happen to fly through that, you get swamped, as you're talking about, like having your transmitter too close to your receiver. All it sees is that.
Yeah, it's the RF equivalent of you trying to have a phone conversation while your neighbor's blasting death metal.
Yeah. Yeah, well, it's cool if you like death metal, but
ask my neighbors.
Yeah.
Sorry.
I was just gonna say, and these pop up in the oddest of places because it may be a dam, it may be some agricultural items, it may be a meteorological station, or there's so many different uses, so you never really know. Even if you're out in the middle of nowhere, your RF environment isn't guaranteed to be clean.
Right. So the reason I bring this up and we talk about this is because we're going to talk about LoRa, and then we've had this conversation before about why doesn't LoRa have the same problems as other 2.4 gigahertz. So, but let's get into LoRa. You were talking about the SIM. Mark, you're going to say something?
Yeah, I have just a question at that point, if that's okay. You said before that with the existing technologies like these wireless USB, for example, there were also things around like Bluetooth and Wi-Fi and all that stuff. You said the hardware is not made for this, for like low bandwidth, high range. One thing I always wondered was, when I compare that today with systems like OpenHD as an example, they also use Wi-Fi chips, but for these chips, they take a lot of control by the software and basically tell the hardware just to send very, very slow data rates to get this range back. So my question is here, is there so much hard-coded in many Wi-Fi or Bluetooth chips that's just not possible, or is it just a software and performance thing to basically generate the needed data rates and signal in software?
And the answer is it's a little bit of both. The newer the chipset, the more control there is in the firmware. We've seen one of the major changes, and I'm going to call it Spectrum here because it's well known that the Cypress chipsets that Spectrum used for all their radios went out of production in the late 2010s. What they did is they replaced that with a different chipset that uses what's called a software-defined radio. These newer chipsets. A chipset from 20 years ago was very, very limited in what it could do. Typically, 80 or 90% of what you could do around in terms of protocol was baked into the hardware. And while you could adjust data rates, you were still at the signaling level heavily, heavily dependent on on what was baked into the hardware. This is how you get For example, you can get receivers. You can take a receiver that's built on one system. And there's a fellow in the UK, I forget his name, who actually took some FreeSky receivers and wrote high-tech compatible firmware for them, and eventually Futaba SFHS compatible firmware for these receivers, because 80% of the protocol was actually baked into the hardware. He just needed to figure out what the differences were in the settings and the data frames to enable it. But you didn't have a lot of control. Modern tech, you have way more control, and you have a lot. So the hardware is a lot more flexible. You have more control over what's happening at the firmware level. So you can then optimize for your use to an extent far beyond what you could do with the old systems. Even Spectrum, they picked up a nice range bump when they went to the new SDR chips, because they were able to get better performance out of the software than they were able out of the hardware, the old Cypress hardware they were on.
How new is that? I'm sorry. You mentioned those chips. How new are those? Are they the same time as the antenna-less receivers that they have?
The antenna-less was actually the first iteration of those receivers, of that hardware platform on the receiver side. They did it on the transmitter side as well around the same time.
Okay, Mark, go ahead.
So this basically also explains why there's, for example, the 4-in-1 module as a multi-protocol module, because some of the RF chips do things that the others cannot do in hardware. It's not just a pure firmware thing, or even the rare 5-in-1 modules that also support XpressLRS with LoRa and all that stuff.
Yeah, and technically, if you had a really modern SDR, you could actually it's actually possible that you could replace all 4 of the chips in a 4-in-1 with a single chip, emulating everything in firmware. It would just be an absolutely massive amount of work, because you'd not only have to reverse engineer the protocol pieces that ride on top of those chips, where 70-80% of the protocol is actually baked into the hardware, but you'd have to reverse engineer each of those chips as well.
Hey, as long as you're talking about the 4-in-1, what I've heard that the 4-in-1 modules, one of the chips itself is going out of production, and so the 4-in-1s might be coming harder to come by in the future.
Yeah, and that's actually why you've seen some that are CC2500 only on the low end, because the Cypress chip, again, the one that gives you the Spectrum chip, the one that gives them Spectrum compatibility, as well as a couple other protocols, has been out of production since around 2018. They're sitting on stocks all over the place. Spectrum alone, or Horizon alone, was sitting on a fairly large stock when they heard it would go out of production. They bought up a bunch so they could manage the transition. So there's stock out there, but that stock's evaporating because none of these chips have been made in 5 years.
Okay. So that means get your 4-in-1 module while you still can.
Yeah. But there are possibilities for the future to emulate these protocols in more powerful new hardware.
Fantastic. Yeah, they're going to have to get to work on that, though. Okay, so back to these LoRa chipsets. So I guess the first question is that when we're talking about 2.4 gigahertz, and we just covered why you're having problems with 2.4 gigahertz on the old traditional 2.4 gigahertz range. When you fly through something and get swamped, why isn't this a problem with LoRa 2.4 gigahertz?
So, and the answer is it is. It's still, the issues are still there with LoRa. What you have, however, is you have hardware that's optimized for long-range usage. LoRa, just to be clear, LoRa is an actual trademark of Semtech. It's specific to 2 of their families of chipsets. There are other chip manufacturers that could deliver similar technology. It just won't be called LoRa. Right now, all the systems out there that we're seeing are based on the Semtech chipsets, starting with TBS Crossfire some years ago, and now moving into we've seen over the last 3-4 years move into 2.4, and even increasing mainstream where you can actually go into your hobby shop and buy a radio that's based on these chipsets. And what it is they've taken these are chips with a lot more processing power. Thank you, Moore's law. Processing power doubles every 18 months or so. They've got more processing power. They're optimized for signaling that is designed for long ranges and lower data rates. And from our perspective as hobbyists, even our short range stuff is long range from an RF perspective. For example, wireless USB. Short range in that community, short range means Bluetooth, where you get 25, 30 feet of range. Not where for us, short range is Park Flyer, where you might get 300 meters, or around 1,000 feet for the folks down in the US. So you've got the LoRa, this LoRa tech, which is designed for data links that go around up to 10 miles. And that is for, IP data links for internet connectivity, not super high speed, but not low speed either. And of course, we send less data. We're sending relatively small frames in the, up to a few kilobyte size frames. So over the same period, so we can stretch that out even further. That's how you get out to the 100-kilometer ranges that we've seen. But the other aspect to that is because of this better optimization, when we take a range hit from swamping or something else like that, we've got way, way more headroom. And so if you lose 50% of your range using wireless USB, you're down to 750 meters or a kilometer of range from 1.5 to 2 kilometers of range. If you're flying 50 hertz ELRS or another equivalent, you lose 50% of your range. You still got 50 kilometers of range left. They're just much more sensitive, and so you still take the hit, but it doesn't affect you in the same way.
Mark.
There's a question in the chat. I might rephrase that a little bit. Andrew Moore is asking, are Crossfire's days numbered? I would rephrase that in our traditional RC link systems, days numbered. And this, I think, also would include systems like Crossfire, like R9, Access, ACCSD, Spectrum, how they are there. What do you think about that?
My take on it is, for the traditional 2.4 systems, certainly their days are numbered, because the person running a LoRa system, even if they're flying line of sight, even if they're flying Park Flyers, they're just that much more resistant to RF signals or to RF interference, that your link. There are huge benefits even for the line of sight flyer with these new technologies, because the link's just that much more robust. And this isn't to rag on the traditional systems. They were an excellent implementation based on the technology at the time. They deliver enough range to the average user, but when they do get hit, and they will get hit, everything gets hit, they're going to take more of a hit than something like ELRS or Twin or Ghost. You've got transitional technologies as well, and I consider Crossfire and Tracer to be transitional technologies. They're running on the newer hardware, but they're not necessarily taking full advantage of the signaling possibilities from LoRa modulation. And my expectation there is we're just going to see development. You're going to see newer versions of the protocol, newer firmware, because they have the opportunity to take further advantage of the technology via firmware updates. So
I did want to talk a little bit more about the cross. Mark, did that cover the question?
Yeah, we covered the question. I just would like to add one point here. So in general, we also have to keep in mind Crossfire and R9 as two examples for long range systems in the 900 megahertz band. They are already using LoRa. The same is for Immersion RC Ghost, for example, and in the meantime also Tracer. Tracer at the beginning didn't use the LoRa protocol of the Semtech chips, as far as I know. So basically, these systems are still in their hardware state of the art, and they don't lag behind.
The hardware, yeah, you're 100% right on that. The hardware is state of the art. The firmware is running older technology. It's not running the full LoRa modulation, but these makers have the opportunity to update that firmware and either add new modes or just provide updates for their hardware to improve the performance. And I think we'll see that.
So as far as Crossfire is concerned, because I mean, we're not here to talk about really. I didn't want to have this conversation be about any specific vendor of hardware in general. But TBS Crossfire is unique in the respect that it was really the first one to come out with 900 megahertz and get it right. But it's different than other ones out there in that it does not use S-Bus. So this is a different technology, right?
Yeah, so that's a totally separate actually aspect to it. There's no aspect of the control link is tied to S-Bus. That is how are you formatting the data when you get it out of the receiver. They're using their own proprietary CRSF protocol, and I just want to call out CRSF is proprietary, as is S-Bus.
But what Crossfire can output S-Bus. You can actually set on the receiver to output S-Bus.
And interestingly enough, Crossfire can also do DSMX remote receiver protocol, which is something that you don't. There's some interesting games you can play with Spectrum stuff in Crossfire, but that you can't do with some of the other systems. Like ELRS uses CRSF as well, and I know they've run into some limitations because, for example, the supported telemetry sensors in CRSF are very, very focused on TBS's core market. We've seen already HTX's extended CRSF sensor support to add barometric altimeters, which is something that was never supported by TBS. And we'll see more and more of that as things come out. And I think you'll see TBS adding sensor support as these new technologies become more popular in the fixed wing world, where you're going to want things like turbine telemetry. You're going to want servo telemetry. That's a big thing in some of the high-end servos. You've seen that from Futaba, from Jetty, from Powerbox, and from FreeSky at this point. I expect Spectrum at some point. They've got all the support there. They just haven't released any servos with telemetry.
Yeah, that's by the way, that's also similar for the Ghost system. They also support multiple receiver protocols. Like they have their own GHST protocol. I think they also have S-Bus and DSMX, but I think they use DSMX2 because of the speed, but I'm not sure about that.
So they use SRXL2, which is what Spectrum has. It's a evolution of the old SRXL protocol. SRXL, by the way, was not a proprietary protocol. It was a industry developed open protocol. It's also used by Graupner. They call it SumD, and a couple other vendors. SRXL2 is a proprietary Spectrum development of it, but it's designed to bring it to the next level, add speed, a ton of extra features, most of which nobody's taken advantage of at this point. The spec list is very interesting, but it's got one really cool feature, and that is it doesn't use inverted serial signaling. It uses standard serial signaling.
Wow.
Which means that you can support it on soft serial ports very easily.
One thing I heard in the community, I mean, I took that with a grain of salt because it wasn't an official high experience source, was that the CRSF protocol is currently the fastest receiver to flight controller link protocol on the market.
It is currently. There's a couple other that are as fast as you typically saw with implemented with CRSF, but CRSF does support the highest speeds currently. That's not so much a protocol level limitation as an implementation limitation. You could, if you really want to, if both ends of it support it, there's nothing that says you can't run 1 megahertz signaling on S-Bus, except nothing actually supports it. SRXL2 and F-Bus are the next two. Jetty's EX bus is pretty darn fast as well. You're seeing there's a lot of development of high-speed protocols in the fixed-wing world because of the desire to be able to get telemetry on your turbine jet or your high-end IMAC aircraft or Top Gun level scale aircraft to get servo telemetry from 10, 15 different servos. And that just eats bandwidth and requires a high-speed protocol.
Yeah. But then you also have a limitation for the over-the-air protocol, of course. Yeah. I guess that's the bottleneck right now.
Yeah, and that's why you see evolutions where a lot of protocols, where you've got selectable speeds. Just to call out, like ELRS has 50 hertz mode, and they've got 500 hertz and 1 kilohertz modes. So you can FreeSky, which obviously is one of the ones I'm particularly familiar with, has their 4 millisecond race mode when you need speed, pure speed, and then your typical 7, 14, 21 millisecond rates for when you need more channels, more data rather than more speed. And you're going to see that level of flexibility start to show up more and more because not everybody has the same needs. I don't. If I'm flying a 5 servo pattern ship, I don't have the same needs as when I'm flying a 9 servo competition sailplane. In one case, competition sailplane, I need range and I need channels. On the pattern ship, I need resolution for absolute, so it's locked in, and I need speed to reduce my latency because I'm flying that thing at 15 feet above the ground at 150, 160 kilometers an hour.
That's and I wanted to go back to the one, that protocol C. It was what you were talking about, the new open source starts with a C protocol.
The only one we mentioned that was open was the old SRXL, the original one. CRSF is a proprietary TPS.
Okay, so the old SR, what was
SRXL. That's what Spectrum called it. You can call it SUMD as well. SUMD. That's what Graupner calls it. I think Jetty and Multiplex also supported it. Sorry, not Jetty. Powerbox and Multiplex also supported it.
Okay, right. So what's the possibility of someone like a bunch of people in an open source community supporting this and taking it on like an ELRS project?
I think it's very valuable, but there'd have to be a use case. And actually, ELRS, at some point, my expectation is ELRS is going to run into a situation where they need control over their wire protocol, where they're hitting limitations, they want to do stuff, and they can their choice is either extend CRSF in a manner that is going to be unsupported by a lot of stuff, or bring something new to the table. And SRXL would be a good starting point for them. Take something that's reasonably open and then extend it to meet their needs. There wouldn't be, or they may choose to develop something in-house.
Yeah, I mean, going back to what you were saying about the telemetry side with Crossfire or the CRSF wire protocol, looking in INAV, I've seen that. And to actually add a telemetry sensor in INAV to Crossfire, you need support from the other end. Whereas with SmartPort, you can just add whatever sensors you want. It's very simple to add sensors in that respect.
It's basically just a data stream, a plain data stream. Oh, okay.
There'd also be the possibility of one manufacturer who does have to open up their protocol. SRXL2, I'll call that out. Spectrum's published the spec for it publicly. And that is, they still control it, but it's a public spec, as is SBUS, as is CRSF. There would be, an opportunity for an enterprising vendor potentially to decide to look at something in that space and expand it. And actually, I just noticed there's a question in chat. Somebody asking me what the Tamiya kit's behind me. That's actually just an empty box that I'm using for storage. It's an old one. It's a 1/72nd scale P51D from Tamiya. Yes, I built plastic scale as well.
Hey, with that, what we should do right now is we should take our 1 hour break, come back. Mark had a question for me last week. Mark, I gave him kind of a generic answer. Maybe we can get a better answer from you, Adam, and we'll come back to that. And we'll also come back to discussing INAV, the new developments in INAV, and some bugs that were recently discovered. So we'll be back in 3 minutes. Hang in there, everybody. Hey, everybody, we're back, and we actually have a question from Mr. Mark Hoffman. Mark, you have a question that you posed to me about a week ago, and I gave you kind of a so-so answer to it, but now I would like you to ask it again, and let's see if Adam can take this one on.
Yeah, so that's a question for Adam, because I know you have some contacts, especially at the development section for FrSky. And my question is, as I use the R9 system mostly on my wings, is it possible somehow, or can you maybe convince them to give us the ability to free up channel 16 on current access receivers? This is really annoying that we have a 16-channel RC link system, but channel 16 is reserved for RSSI output to the flight controller and not to our actual control. And is it possible with access to get link quality telemetry on your radio and on the flight controller?
So in terms of link quality, I haven't checked the R9 lately. I know it's there on 2.4 gigahertz is the VFR sensor, which
that's
is
that's on R9 as well.
Okay, so that is functionally that is your link quality. That is how many of the last the last contiguous block of 100 frames was received that was good, and they picked 100 frames because it makes the math easy to percent. If you lost 10 frames, you've got an out of 100. That's 90 good frames. That's 90%. Getting that into the into the flight controller would be really, really good, and that would be, I would see that as something we would want to include in FBus telemetry from a project. I would really like to see that move over to the telemetry link from eating up a channel like for RSSI. That's, that was a great workaround back in the day. And that's something I will very definitely pass that on to engineering.
Yeah, I mean the having the link quality on the radio is a good step in my opinion. We don't had that on ACCST as well.
Yeah.
But at the end, my telemetry output power, for example, is a maximum of 100 milliwatt, and I will very likely outperform my telemetry range, especially on legal power levels at all. And if I don't get the link quality back on my radio, it's basically useless when my RC link is still up, and I don't know what the RC link quality is right now if I don't get it on the flight controller.
Yeah, and I agree 100%. Especially if you're flying FPV, you don't want that on your radio. You want that on your screen. You want to be able to see that, and that is key. And that's something I will very definitely pass that back to the folks in engineering. That this is a change that they're going to want to put in. I would expect that to be data that would be put into the FBus link rather than trying to backport that onto S-port or F-port.
Even if it's backported, in my opinion, if they force the channel 16 on the RC link to be RSSI currently, then at least let us switch to give the link quality out on channel 16.
Yeah.
That would be just at least an acceptable change, compromise.
Yeah, and agreed. And there's actually one other reason that I particularly want to see this, which is right now, if you're running a redundant receiver setup, you have no idea what the link quality is on the receiver that's not active. And that be whether you're running dual band or dual receiver in band. And I know this has been brought up before in the past. It's very definitely on the radar. But being able to put that out over the telemetry means that you could consume it by a different receiver and send it back, and either the FC or a second receiver to send back as telemetry.
Because right now I think if you have redundancy and the system switches to the backup receiver, you don't get telemetry from the flight controller anyway.
So
because it's only S-Bus. S-Bus, yeah.
That depends on what system you're running from, and getting into the free. This would be a little in the weeds for FrSky. If you're running Access, Tandem, or Twin, you can do that. You can't with Twin right now. Access or Tandem, you can do that. ACCST, you can't. So Access and Tandem allow you to have a shared S-port line for telemetry. So both receivers are connected in. The only caveat with Access is you can't do that dual band. The telemetry's all got to come back to only one module on the radio. Tandem, because the two bands are integrated at the module level and at the receiver level, can share that across. But
so what I just had in my head is if you put two receivers like the R9MX or the R9MM no, not the MM, the R9 Mini. The R9 MM has no redundancy input. The R9 Mini or the R9 MX, and you have two of them in a chain. I think they have only S-bus input, so the flight controller cannot route the telemetry through the first one to the backup receiver.
Yeah,
that's just what I meant.
If you're running S-bus or F-port, you are limited that way. There are ways to share external sensors using S-port, but it really does depend on what the setup is. And it's, we've come a long ways, but there is a ways to go to get to where I'd really like to see the capability, where it doesn't matter what link you're using. If you're using multiple links, you're getting every piece of telemetry is sitting on that telemetry bus, so any receiver can send it back, and any device can consume it.
Interesting, fantastic. I did want to also bring up one thing, which is, I just want to say something very quickly as far as talking about FreeSky. Things are going great with FreeSky. My 9-to-5 job is going fantastic. It's a love fest. I'm very happy with the company. They're very happy with me. Everything's great. The only problem is I work 6 days a week, and Sunday's my day off, and so I don't answer phone calls, and I don't really talk about the company on Sundays. I had to put that in there because the phone was ringing 7 days a week, and I've said enough is enough. So that's why I don't wear the FreeSky hat on Sundays. But with that being said, I did wanted to ask Darren one question, which is, long time ago, Mark Hoffman and I had for months, we debated setting up an OpenTX model for INAV. And this was, Mark and I went back and forth, and when we're done with it, I said, okay, Mark, you can write it. And Mark said, great, I don't own an OpenTX radio. True story. So we put out the specs of the group and like, hey, can someone help us write this OpenTX model? And then there's this guy that had long, stringy red hair, and I'm like, Mark, I don't know this guy. He looks kind of weird, and it does not look like he would know what he's talking about. And then
don't flag it.
It's just a true story, and all of a sudden, okay, we'll give him a shot. And what he came up was with the group model, and he also did the documentation. And this was when I knew the guy was freaking brilliant. And that was Darren Lyons. That's how we discovered Darren Lyons in the group, was this whole model. Now, we have this Ethos operating system, and Darren says he will not write an OpenTX model or an Ethos group model for the time being, and he can explain why. And then we're going to ask Adam if there's any changes that will change how this might proceed in the future.
But the main reason at this point in time, and I'm pretty sure I checked the firmware again with the latest release, is you can't disable or enable trims based on the flight mode. You can only say change the trims per flight mode. It's not anywhere near as flexible as you could do it with OpenTX. And for example, I want to make sure that the only time trims are active on the radio is when we're in manual, because of course any trim in any other flight mode is seen as an input. With OpenTX, that was really easy to set up. I could have manual trims on one, or trims active on the manual mode. In other modes, they're actually set up to do other things. So with the OSD over to the tuning, you can use it to do the manual tuning, that sort of stuff. And at the moment, it's not quite there from what I've seen as far as the flight mode side is concerned, for being able to say, have the trims turned on and then trims turned off for a different flight mode. You can have it so that flight mode 1, the trims are X amount, and in flight mode 2, they're X amount, but not actually switching them on or off. for different flight modes.
Right. And so there are some people who actually will fly in manual mode, but they want the freedom of having return to home in case they fly too far away.
Yeah,
Well,
it was.
Oh, go on, Mark.
Yeah, it would be also very helpful for more experienced flyers for tuning. For example, if you don't want to rely on a constant automatic trim, but use the classic auto trim to have it really spot on, you can basically switch into manual mode. You do your trimming of the plane, and then you just switch back into auto mode without messing everything up. Or an acro mode or angle, return to home, whatever, without messing it up, because the trims are just reset and disabled at this point. And then you can land, just look what your trims are, set it mechanically. You can do all that with this feature. And as Darren said, we also use it on the OpenTX Pro model, especially for the in-flight tuning. So we navigate through the items on the OSD with one trim switch and change them with another one. I use it on my personal setup to zoom the map on my radio with the Horus mapping widget.
Yeah, and that's available for EFOS now, so that's another good reason for having it.
Yeah, and I also use the trim switches to switch between slider controlled pan and tilt or trainer mode pan and tilt with my goggle head tracking. So I don't have to use a switch. It's easy to just have a trim switch. Pushing up is goggles, pushing down is sliders. So this is really helpful to have them free.
There's loads of other things as well, like VTX power levels. There's so much stuff that you could put on those trim switches, but you need the ability. I mean, I could have them turned off for everything, but then you lose the ability in manual to do a little bit of manual trimming, which a lot of people, especially old school pilots, they like to do it that way.
So in short, we need that for ethos.
And actually, everything else is done. I've actually got a model set up on my transmitter, and most of it is working. It's just this trim part, and then.
Yeah, a couple comments on that. First off, there is some love coming to trim. Right now, they're already, if you try the 1.5 nightlies for Ethos, and you can take advantage, you can lock out trimmers at this point by using the new VARMix actions that are being introduced. And these are the replacement for GVAR special functions in Ethos, from OpenTX or EdgeTX. Imported into the VARMix. There's a lot of changes underway right now. The current nightly is not what is going to ship. I know there's some new stuff that's going to be available for testing next week. That said, there are some ways to do what you need using Ethos as it stands on 1.4.6 or 1.4.7 now, but they do require you to use to not use the canned aileron, elevator, and rudder mixes. You got to use a free mix or two for those, and then you use a second one. If you're using a free mix for your control surface, then you can have a second free mix for your trim. Maintain per flight mode trims, because that's set up in your trimmer menu, and then just have that trim mix, trim free mix, I'll call it, because there's another kind of mix called a trim mix, but you don't need that for this. And you can have it only active in the flight modes you want.
Yeah, but you end up sort of just doubling everything up effectively, don't you?
You do. Yeah, you end up with some more mixes, but it's going to get wordy in your mix. You're adding mixer lines. It's going to start looking a lot more like OpenTX in your programming than it would like the relatively minimal number of mixes you might be able to get away with in Ethos. And that is one of the things about Ethos is you can, for the most part, program it. Everything is a mixer line like OpenTX or EdgeTX. It's not 100% the same, but a large part of that style can be done. Or you can use the function-based mixes like you might on Spectrum or Futaba or Jetty, or you can mix up both of them. And I tend to do that as a really look what's my use case for this particular model and decide which style I'm using. I even mix them up. For a long time, all my throttle mixes were actually a couple of free mixes rather than using the canned throttle mix, because at the time the throttle mix was just limited on input sources.
So you mentioned 1.5. Is that going to be coming out? You know, that's the dangling carrot to say. How soon before we actually see it? This is Ethos 1.5 we're talking about.
Yeah, Ethos 1.5. I don't know. It is actively in development. It is what we're working on right now. And just for clarity, I'm a beta tester for Ethos. I help manage the GitHub from a community perspective. So I am, while I'm not doing the development, I'm very much involved in the testing for it. So it is actively working, but right now we're about 25% through the open issues that have been tagged to 1.5. No ETA. It really, and this is the same for all the Ethos releases. When you get to a point where we feel that it's ready to introduce to users, a pre-release will be put out. We'd like to let that bake, depending on the number of changes, for a few days to a week or two, and then it hits stable.
Just one thing while we're talking about trims and Ethos, if I don't ask, my subscribers on YouTube will kill me. Is InstaTrim coming in the next release? Because that is something that people are. I've actually had an email yesterday saying someone's had bought an X18. They're not happy with the screen, so they're going to sell it and either get the SE or the X20, but only if InstaTrim turns up. If not, they're going to get another radio with OpenTX. People really, really want InstaTrim.
And I'm well aware of that. I am one of them. And this is something I've heard from a number of folks. This is a beloved feature for anybody who's used one of the more powerful radios, whether you come from even old school. If you got a MicroPro 8000, for those who remember ACRC, that was the first radio out there that was truly flexible. Came out in the late 80s, early 90s. Actually, I think the late 80s in the US. The multiplexes like the MC4000, seen it, Jetty, Powerbox, whatever, OpenTX, EdgeTX. Everybody loves this feature.
Can someone quickly explain me in 3 sentences what is InstaTrim?
So, InstaTrim is straight up. You have an aircraft that's out of trim. You're flying it. You get it into a level position where it's flying level, and you're holding the sticks. You hit a button, and one of two things happens depending on the implementation. Either the trim shifts over time to match your current stick positions, or in the case that's what's called auto trim. Or the trim comes in, you let go of the sticks, and as soon as it engages, and then you're pretty darn close to trimmed out. It's a great way of getting an aircraft that is flyable but out of trim into something very close to ideal trim very quickly.
Okay, so basically the same continuous servo trim as INAV can do and Autopilot can do, or alternatively the old classic auto trim that INAV does, where it just saves the instant position or the average of the last few seconds of the positions.
Exactly. Okay. And this is everybody I know who has tried this seriously and had to trim out an aircraft that they've taken off and it is significantly out of trim but still flyable, loves the feature.
Yeah,
yes,
makes sense.
It is currently on the to-do list for 1.5. It's been on the to-do list for a while, but 1.5 is where we're addressing a large number of those items that have been sitting around for a while.
Cool.
So speaking of flight controller features, I think, Steve, it's time to move to INAV. We have 40 minutes left.
INAV! Hey, fantastic. What's going on with... You know what? I was flying with the pre-release of INAV 6.0. Just, Adam, that you're aware of what's happening, we've... INAV had one serious drawback. It was going on for many years, which was that we had horizon drift. If you had a well set up plane, it would be about 3% out of the horizon would drift about 3% down, sometimes get worse throughout the flight. It would affect the way that your plane flew sometimes in things like return to home or whatever. And about a year ago, we were talking about how can we fix this. And long story short, it would take a lot of math and a lot of work, and we weren't certain that it was gonna. We were almost had a bake sale fundraiser, so we could get enough money to help pay for development time for our developers to do this. And even that didn't look like we could get that together. So it looks like this was something that would never be fixed in INAV. Now they came up with two solutions to it. Mark knows more about this than I do. I got to actually fly with it in the pre-release. It works fantastic. No more horizon drift whatsoever. Hallelujah. So Mark, talk about that.
So yeah, I think we don't need to go too much into depth about that. Again, we talked about in one or two of our previous Wing Talks about that already, especially in the feature preview 1 special. But in short terms, what INAV does now is it checks the GPS information, the vertical speed information from the barometer, and even the accelerometer data to estimate in real time how the plane currently moves in space relative to the ground, and uses these information to calculate the g-forces that are created by turning, by pitching, and all these movements the plane can do. And by knowing these g-forces and the estimated vectors of these g-forces, they can completely removed from the actual sensor reading, and all that it's left is the actual gravity vector that points straight to the ground. And this is how INAV currently is able to always determine where the ground is, even if you fly long, slow turns and all that stuff. We had a lot of mitigations in the past where in turns, when the turn rate overcomes or passes a certain threshold, that the accelerometer is just ignored completely, but that only works for a certain amount of time until the natural mechanical gyroscope drift takes over and adds up over time. And it also causes very slow realignment if the plane levels out. So this is all a thing of the past now, unless you have a really, really badly vibrating setup or electrical noise that messes with the sensor data anyway. This can, of course, still cause trouble, but yeah, you cannot say it's INAV's fault then if it's so bad. But yeah, INAV is finally able to reliable fly and navigate itself without the risk of losing orientation and crashing during return to home or loiter or whatsoever. So this is a really big step. And not only does this massively improve the flight behavior itself and of course the reliability, the side effect of this new implementation of this update of the AHRS, the Attitude and Heading Reference System, this system now also can give out more data to the rest of the INAV software modules to allow even more features based on that. There's one feature still in development. It didn't make it into 6.0, but it's really interesting, and that's that GPS dead reckoning navigation. That means if you lose your GPS signal for some reason, like a military test somewhere, you guys in the UK know that very well, that the military starts to jam the GPS systems for testing purposes. And if that suddenly happens, the plane is actually able, based on its direction, based on compass, the airspeed it has, and all these information, and the barometer altitude, to navigate back home, even with no GPS. And when I did one test in the field with some gusty wind, and on a 2.5 kilometer long waypoint track I set, the final home point was just 200 meters off. So it works pretty well. There is some feature changes that need to be done, but that works really well. So yeah, this is basically a very big deal for INAV and also the future development.
It's fantastic. Now, let's talk about the betas, because what happened was we were on a 6-month beta schedule, and we had people who were like, I didn't get the last beta in my planes. Now we have a new one out. And so we went to about 9-month, and maybe in the future we might go to about a 1-year beta release schedule. But we're at 9 months right now with this one. We have a beta out. We had the second release out, and we found a bug in this. So Darren, can you talk about that, please?
Yeah, I just want to say they're not really beta releases. They're testing releases, but there's already been a lot of testing done already. It's not really beta. It's just like a mass test just to pick up the final last bits. So it's I think beta might put a lot of people off. Having said that, I've got a question for everyone else a little bit later on, relative to that. But yeah, actually, it was actually. Sorry, one sec. Yeah, sorry. It's actually Leslie who found this bug. And it was only in Configurator. If you all read the release notes, which I'm sure you did, you would have seen that the AHRS renamed the parameters basically so that stuff wouldn't get carried over from the old version. And unfortunately, some of these parameters are getting set in the default. So when we create a new fixed wing model, one of the first things that we'll do once we've flashed, we'll open up, Configurator will get connected to the flight controller, and we'll get this box up saying, choose your default platform. And we'll choose either aeroplane with a tail or aeroplane without a tail.
Right.
And when with RC2, we clicked one of these boxes, because the parameter name hadn't been updated, it sort of skipped about 5 or 6 different parameters after the the AHRS parameters. So they weren't getting saved to the flight controller. So you could have issues with your setup. And that's one of the main things that RC3 is fixing. So you can create new models now and it will work absolutely fine. Okay. So yeah, if you're running RC2 Configurator, delete it and download RC3. The firmware is fine on RC2. If you're running RC1, get rid of all of it and get to RC2.
It was also a little bit my fault. Yeah, so I worked very close with the developer who did that AHRS update, and when the feature preview 1 was released and we published some new of these parameters that had the same name as back in 5.1 for the mitigations, I talked to the developer and said, hey, maybe we should rename them, first of all, to get it more unified in the configuration, because we had 2 new variables that were called AHRS underscore and so on, and then the old mitigation starting with IMU underscore and so on. And then recently I told him, hey, let's change these settings. People don't read the freaking release notes properly. And if you take over your old 5.1 diff to 6.0, you would take over the old mitigation settings that are too low for the new AHRS and could cause trouble. So he changed that. But I didn't change in time the profile to remove these settings. And we also thought, okay, if the settings are not there, they are just skipped. But actually, it messed up a few more settings afterwards. So, yeah, that was the story behind that. And regarding the beta phase, all this AHRS stuff basically started after 4.1. Shortly after that, there was one developer trying to port over the Autopilot AHRS, the old one. I'm not sure how it was called. Darren, the DCIS, DCS, something like that.
Yeah, I can't remember, to be honest.
The Autopilot backup AHRS system. Yeah. He tried to port that over to INAV. It was working, but it had a few bugs he never could fix, unfortunately, up to 5.1. So there was actually a chance if that had worked, then 5.1 would already have this in. But yeah, it didn't work out, unfortunately. And then the other developer came and he did a more a more reduced approach, and by updating the existing AHRS with the same needed math behind it and formulas to do that. So all the testing about that stuff really started about a year ago already. And with the feature preview one, to say it simple, it's basically an INAV 5.1 with the new 6.1 AHRS implemented and a few code blocks additionally, just to see over a very long time span. I think it's 4 months now, 5 months.
Yeah, it was October it came out.
Since October, yeah, 5 months, to just see if it's reliable, if it has issues, and so on. There were no problems, so just RC1 is the first real 6.0 feature complete release candidate, and from there on, now we are just basically fixing stuff.
6.0, not 6.1.
6.0, of course.
We might, if what I've submitted this morning gets approved, we won't have a 6.1.
Yeah, I've seen that. Yeah.
So is this why you're saying this is not a beta? It's been tested. The point you were making.
Well, the point of it not being a beta is like when you develop the stuff, the first testing is done by the developer themselves. So, for example, if I write something, I'll test it, depending on what it is, I'll test it in the hardware in the loop first, make sure it all works in there, and then test it on a physical plane, make sure it all works. So that's really the alpha testing. Once I'm happy with it and it gets merged into the master release for INAV, all the other developers at that point are then going to be using that code. And there's also people such as a guy called Jetrel in Australia who will download specific pull requests, pull requests and or the master, and will test specific functionality out as well. So that stage there is really the beta testing. So when it comes to release candidates, we're already pretty certain that this thing is going to fly pretty well. So it's just sort of mass testing to make sure that everything is going smoothly. And once all the tiny things are ironed out, that's when the stable release comes out. So it's Sorry, Mark.
Yeah, so the fun fact is actually, if one developer is testing his own feature with his brand new code the first time and does an alpha test for his feature, he is basically doing at the same time a beta test for all the code that came in before.
Yeah, and anything that his new code is, or their new code is touching, they will also be testing the code that it's based on. And if you're test flying something, that could involve pretty much anything. So there's a lot of testing that goes in before the release candidate phase even begins.
So this is interesting because, I mean, what you're saying, is this common for, let's say, hardware manufacturers as well to do the same thing?
I wouldn't have a clue.
Adam?
I know that's what to do with INAV, but yeah.
Yeah, it's not uncommon. After 30 years in the IT industry, I've seen this approach to releases a whole lot.
So, okay, so this is fairly common. That's why when you have a release, because I wonder about this, when you release this to the mass, because my belief is that you're going to find weird stuff. People have weird setups and you uncover things you might not uncover before, but pretty much the big pieces have already been figured out. Some refinement is all that's needed. Is that what you're saying?
Yeah, typically, like, there's always edge cases. You can never have a big enough test pool of people to uncover every issue. But the big stuff should largely be dealt with. You've got your nightly type testing where you've got developers and or testing a pull requests where you've got the developers and a small group of core testers who are heavily involved in testing that stuff. For example, I do some of that for Ethos. There's builds that we've only started doing nightlies there with 1.5. Prior to that, any of the test builds were going to a small community of dedicated testers. Then you might push out, if you've got a beta where you want input from a wider community on a particular feature, You push out a beta or a test build to those features. Then you've got your release candidates. These are the candidates where you think that there's a good chance they're not. The functionality is tested, but you're pushing it out to a larger community to see, for them to catch what bugs you missed, to see if it's ready for release. And you go through a few release candidates, and when everything seems nailed down, or you've identified that maybe one or two features need to be pulled from the final release for more work, you get everything nailed down, then you get to your release. This is very common. I see this. I do a lot of work with open source software. I've been working with Linux since kernel was around 0.96 or so. I've seen it across the board. It's one of those things with modern development you're just going to see. And the alternative that some manufacturers do is they do all their testing in-house, and then they roll out a major new feature that everybody hates.
Yeah. From my perspective, I have seen it from both sides. I'm a few years now working with open source developers, INAV especially, and as we said before, we have here this stage testing. So every feature that is alpha tested goes into the major code, and everyone who develops a feature afterward uses this current stage when he starts to merge his stuff or test his own stuff. So you have a continuous beta test with an alpha feature on top. I think that's actually very common in open source software, especially because everyone who works on the code works on his own. If you have a corporate or a company working on closed source stuff, I have seen that also on first hand. I worked many moons ago for a hearing aid company. They had firmware for the hearing aids, for connectivity systems, for they had their software on the PC for configuration. And there, how they do is that they have multiple teams or multiple programmers. Every programmer has his specialized area where he works on. And what they do is in a team management or on director level, they say, hey, everyone works up to this day, and at this day we will make a snapshot. This will be a beta snapshot, and that is tested. And so the developers have time up to this point to test their code, to do everything. Then they say, this is a beta snapshot. We try it out, test it in-house, or maybe we even test it in the field to see what happens, and then the feedback goes back to the teams and they start to work on updates, and then the next beta snapshot happens. So there are different structures how this software development can work. This is basically a very open source approach, and I think the advantage here is that if, for example, Darren makes a new feature that needs data from another module inside the INAV code, just some sensor information, and Darren finds an issue, he can give feedback directly to that developer. If you have that in that completely island structure as before, they are only working with currently working modules where they build their code up, while another team is working on these modules as well. But the developer working on the first developer working on his feature is not seeing what they do. So they could implement a bug that affects a completely different team, and this is more unlikely in this open source structure.
Interesting.
Yeah, I mean, actually, at this point in time, as far as INAV goes, we're actually in a sort of a weird sort of parallel sort of situation, because the 6.0 RC1 would have been a snapshot of the master at that point in time. But after that, they're sort of developed in parallel. So if there's a bug found in 6.0, which we need to fix to bring out release candidate 2, 3, etc., it's at that point, the 6.0 is actually a pull request itself. So the bug fix gets added to that pull request, and it doesn't actually get put into the master branch until the stable release comes out, when it's all merged back in together. So I could be developing stuff for the next version now, which something in the 6.0 could affect. So there's this weird parallel going on. That's why I think we don't really tend to merge stuff until after the stable release has come out. So then if there are any issues, we've still got to sort of test it again once that happens. But yeah, it's all cool. It's all fun.
Fantastic. So how far along are we before we actually have a stable release of INAV 6.0?
Pavel's always said March. So yeah, okay. March. He's been saying sort of the end of March, but mid to end of March, I think, is probably a good goal.
And that's a great time to have a release, a stable release out, because people are building, getting ready for the summertime. The problem we had in the past is these releases would come out right at the start of summer, and it was like you're building your plane, and all of a sudden you have weeks on one release, one version INAV, and the next version comes out, and you kind of in summertime when you should be flying your plane with INAV, setting it up.
Yeah, that's a good point, Steve. I'm just going to jump in here because one thing I recommend to everybody is if you're flying a release, and it doesn't matter whether this is you're at the SC, at your radio, at your ESC firmware, whatever, and it's working for you, stick with it for the season unless you've got a screaming reason to upgrade on that aircraft. If you're flying this aircraft all the time, it's working. Don't change.
Yeah,
you
and
don't
that
have
was
to change stuff to change stuff.
That was the reason why a lot of people would not update to the most current version of INAV, is because it was too late in the season for them to update. And so we'd have better INAVs out when they weren't using it.
Yeah. But contrary to that, I would say if you are using a release candidate, or which is a testing release, that you do need to update to the latest version when that comes out. Otherwise, what you're effectively testing, if you find a bug on it, it's potentially irrelevant because it may have already been fixed, and also you're not actually testing the latest package. So there could be something that doesn't get discovered because of, as Adam said earlier, the whole point is to get more and more people testing this stuff. The more people we have testing it, the better. So by not updating, you're actually reducing that pool of people testing this latest release. So that's why with release candidates, it's always important that when a new one comes out, you update to it. If it's configurator and firmware, you've got to do both, or just be on the latest. And if you do find an issue, you should report it through the GitHub. Otherwise, it's not really helping the cause.
Can I just say that I'm in love with this release schedule we're at right now, because what I've always noticed about Darren is that around the Christmas time, for whatever reason, you don't have a job that's anything to do with retail, but have all these end of the year projects. And I think a lot of people fall in this as well, where you're busy as hell, and you can't wait for the Christmas holiday to come along. But then you start the year off and there's nothing going on, so you can kind of work a little bit slower pace to get the last of the updates done for INAV, and then we're in beta. I think there was a drop dead date. Was that the end of January? Was that around the drop dead date?
Yeah, 29th was the code cutoff. So after the 29th, anything new that gets developed will be in the next release.
Okay.
Which Pavel sort of has a 6.1 milestone currently for that release. But if anything goes in there which breaks backwards compatibility, which the change I put in this morning will, then it'll be 7.0. That's just the way the version numbers work. But he's also said that the next release is likely to be October, November. So it'll be a very short period for the next release. And then chances are it will be a yearly release at that point, around October, November time, which actually for us works really well, because if you're flying for a full season in the Northern Hemisphere, you've got the whole summer. At the end of the summer, the next version comes out, you've got the winter to update. But also Southern Hemisphere, it's sort of like the near the beginning of summer. So you can do the update, fly the whole summer, and then winter time, you fly when you can and do the update again at the beginning of summer. And from a development point of view, we've got the whole summer to test out new features. So that would be ultimate, I think.
We have 88% of the world's population living in the northern hemisphere, so this kind of works out. Is that, but the time frame works for you as far as that time of the year you're not quite as busy and you have time to test? And
Oh, it's just this one company we do work for. It's the end of their financial year, so they put all their projects into sort of September to December. So that's what causes me all the stress. But as far as for an INAV development cycle, having a release probably November would be ideal, and then sort of release candidate phase maybe starting August. So we get 2 months release candidate, then the release in November, and then we get another 10 months before the release candidate comes out. So winter time with hardware in a loop for development, summertime for testing everything. Yeah, that would be awesome.
By the way, you mentioned something. Now I got to come back to it. You said there's another release of INAV coming out in October timeframe, right? A beta coming out in October. Is there something, and you mentioned something that is going to break code, so it'll be INAV 7. You introduced something. Is there something major coming along in INAV 7 that...
It's not necessarily major. The version 3.0, the way the version numbers updated changed. So before that, it would sort of be feature based. So if there's a big feature or big change, that's when the major version number would increase. But from then on, we used it's called the SEMVer versioning number system. So if you have a change that breaks backwards compatibility, the major version number increases. If you have new features that don't break compatibility, the minor version number increases, and bug fixes just increment the last number. And what I've put through this morning is a pull request. It actually removes something from the CLI that is in 6.0. So because of that, it breaks backwards compatibility, so that the next version would need to be 7 if that's put into it.
Okay,
so it's not necessarily a big feature, but it'd be a handy one.
If we would still make it based on the feature changes, would be like INAV X or so.
Yeah. Oh, to be honest, if we'd started with SEMVer, we'd be on like INAV 15 or something by now. We'd be on a ridiculously high version number. But it's because during that initial sort of the 1 point whatever to 2.6, we were just doing with feature changes, and I can think off the top of my head of about 4 or 5 different versions which would have been major version increases. Pretty much everyone would be.
At least we don't do the Google Chrome and Firefox way. They have like a major release every month. Where are they now? Chrome 150 or so? I don't know.
I don't know.
Anything else about INAV?
Only that we don't really seem to be getting a lot of bugs, which is a pretty good thing. I think I think the fact that the release candidate phase is going quite quietly either means no one's flying it, or there's not really much wrong with it. And considering a lot of people, I think, have started using it just so that they can use like the DJI free stuff, and also the new AHRS, I think there's probably quite a lot of people flying it, and just everyone's getting on fine with it.
Do we know if the HD Zero actually has their screen working with INAV now, their OSD working with INAV?
HD Zero was fine anyway. The DJI 03, it's like when the first one came out, it's still a hack. So we're having to use the Betaflight font set, which is massively reduced. So actually setting it up is using the OSD page, so that's pretty simple. But any elements where the font just doesn't have that in there, then you're just going to get a question mark on screen. I did a video actually about how to set your HD system up on INAV, and at one point in that video I put both font sets up on screen, so you can see them next to each other and just see how much is missing from Betaflight compared to INAV, and that's why the issue's there, and the only people that can sort that out are DJI.
I mean, one thing maybe for the future or for the development after the INAV 6.0 release, I would suggest is that Darren leaves the OSD alone for a while, so all the other ODHD system providers can keep up and finish their fonts and don't have to add new characters all the time.
To be honest, with HD0, it's not an issue at all. With Walksnail, once they sort out the custom OSD side, again, it won't be a problem at all. You can just upload the font to the goggles, which you can get from the INAV repository or from Sneaky. Actually, the Sneaky font has already got stuff that's going to be in 6.0 in there, already laid out. And to be honest, I did put some sort of biggish changes in the font deliberately for 6.0 because I knew at that point it's going to be a definitive release. It's like a reboot of INAV with the AHRS stuff. So there are some biggish changes in the font, but because I knew it was basically starting from zero, most people should be flying that going forward.
Speaking of HD0, just a question from my side. How is their font system working? Do they support custom fonts? And if yes, then also on the module, do you know that?
As far as I know, yes. Because Sneaky or Shannon's got fonts for HD0, and he's actually working with the guys so that the default font you get with HD0 is going to be based or one of his fonts. But yeah, I've been sort of chatting with him to get everything up to date for the next version of INAV. And once 6.0 goes stable, he'll bring out a version with the big one is the logo size. You may, if you're flying 6.0 on some of these HD systems, or if you've not updated the font on analog, when you see the INAV logo, you'll see it's all over the place. That's because it's been made physically bigger. The idea being so people can customize it. And it's going to be put in more places in the future. So the arming screen will have the logo, so you can put your own custom logo on it, stuff like that. So yeah, that will get updated in the future. But at the moment where we're in release candidate, I've not shipped it to Walksnail yet. And I don't believe HD0 has got the new logo size yet. But there's stuff in place to get these updated.
HD0 also now seems to work on a 1080p 30 FPS mode, so I hope that will also work properly, especially then with the logo. Maybe I hope they don't make an additional grid size.
No, I think
we have enough.
Is that the standard definition grid size?
I don't know what the grid size for HD0 is currently. I just saw the post from I forgot the name. The guy who posts all the HD0 updates. Yeah, exactly. This one.
Yeah. My mind's gone blank. I'm
Carl Zhao.
Not Carl. No, anyway, but he posted a video today showing HD0 in 1080p 30 FPS mode because the ASIC is just not capable of 60 FPS 1080p. Looks pretty good.
Ryan
Quillett, yeah, exactly. Yeah. So yeah, I'm interested how that will work, and if they change the grid size again. I mean, right now I think we have 4 or 5 different grid sizes we can select between. I think 5 if you count analog as well.
Yeah, I mean HD0 has 2, so you have the standard HD size. I can't remember the sizes, but yeah, you have HD0 and the standard 16:9 and also the 4:3, which is the same size as PAL. You have Walksnail, which is a different size again, and actually they have, to be honest, it's my favorite size, but purely because the horizontal is an odd number, so your crosshair and your home arrow you can get dead center, so I think that's awesome. I think it used to be 1 pixel or 1 character wider, but they shrunk it down and it's so much nicer. But yeah, so Walksnail's a different size. HD0 has 2 sizes. WTF has a different size. 03 uses standard definition PAL size. So yeah, so that's 4 different sizes for HD.
Cool. All right. So anything else about INAV? Because I do have a question I want to ask. I teased this in the show's summary today.
Oh yeah. My question. So, with the release candidate, we've seen a lot of people taking it up just to get access to the new features. Do you think this, or do everyone here think that this is a good thing or a bad thing, and that release candidates should just be used for testing? Everyone's quiet.
I just jump in here. So, in my opinion, both. Because if we test, we also need to test the new features. And if we have people especially interested in these specific features, we know that these are get tested. I mean, if you are just a casual flyer ripping around with your plane, around you in a few hundred meters distance, and you do exactly the same stuff in INAV 2.0 like you do now in 6.0, yeah, okay, we know the base core of INAV works, but we still don't know if the new features work reliable. So I think, in my opinion, updating for the features to a release candidate is more important than just for testing, basically.
My opinion is that we, going way back to INAV, it was every single new release that came out made it a little less horrifically horrible. And I think we got around INAV 4.0, it got to the point where it was a viable platform. So a lot of people are happy with INAV 4, INAV 5. And if there's a feature they're looking for, I think the last feature they're looking for was this horizon drift. And after this, what I'm afraid of is kind of the opposite. You're going to find people who might be on INAV 6 for quite a while. And, we have INAV 7 come out and they're like, what does this have? Oh, I don't really need that. So, any dangling carrot we have to get people into the next version of INAV is a good thing, even if they wanted to beta test it. Darren's very quiet. He's just thinking about
I was going to see if Adam had an opinion.
So my take on this largely is each individual pilot's got to balance the features versus the risks of using a release candidate. Release candidate generally is going to be something where it's stable enough to fly. And so the risks are much lower than using a beta or a test build. But if you've got the hardware that needs the features, and I'm of the opinion I would fly, but not on necessarily my most valuable aircraft. It's a release candidate is viable enough that it's something that I would fly on the test bed or one of my less valuable aircraft, but I wouldn't put it on my most, until it hits stable, I wouldn't put it on my most valuable aircraft.
Okay. Now the question I have for you is, this came up from the last few weeks. We've in the United States, we've had various balloons floating over the United States, and our government has decided that we should be shooting down things, and it's gone from shooting down things that we feel are spy balloons to shooting down weather balloons put up by amateurs. So it's been an interesting last few weeks, to say the least. But it got me to thinking, if you were to, because every time we shoot one down with a Sidewinder missile, that's $400,000 that's going. And especially if you miss the first time, that's $800,000 to take down something, right? So I was thinking, like, maybe we could do a favor to the FAA and send up one of our INAV planes to take down one of these balloons with a big pointy thing on the front of it to pop the balloons. If they were to get rid of remote ID, it's, one hand washes the other kind of thing. But then the reality is that the range to get up there, 40,000 feet, was about 5 miles. We can cover that with our, we have the range to do that. The problem is when you get up to about 40,000 feet, it's about 150 degrees, negative 150 degrees Fahrenheit. So it's freaking cold up there. I don't know if we have any technology that can handle that. Mark would know this better than anyone. What do you think?
The record, or let's say the illegal record I have seen so far with a normal, it was with a mini Talon, flying high altitude was 12.5 kilometers. So that's
28,000 feet.
How much? 20,000 feet?
No, that's more. It's more.
28.
20,000.
It's more.
The mini Talon I saw was 28,000.
I've seen 12.5 kilometers, but that's more. That's more than 30,000 feet, definitely. 30,000 feet is a little bit less than 10 kilometers. So it's about maybe 36,000 feet or so. That was the highest I have seen an RC aircraft going from the ground up so far. But the problem there is not even the temperature. You can dry out servos, so you remove all the grease, everything, make it completely dry, so nothing is there that can solidify. Of course, they will wear down faster, but you can at least achieve it. The electronics stays warm by itself, as well as the motor, so that's not a problem. The biggest problem is the air density up there, because the propeller RPM has to go so fast, and the prop has to be very big to generate thrust up there. He wasn't really able to climb further. Like, he had a climb rate at the end at 0.5 or 1 meter per second, while from the ground you start with 8 to 10 meters per second climb rate. That's the biggest issue up there. And the highest RC craft I have seen so far was launched from a balloon, up to, I think, 120,000 feet or so. And then it was basically just an RC glider, drop down, and then try to fly back home. So no, you won't reach these balloons with our conventional aircraft. You need a very, very specialized build for that. Maybe even with 2 different powertrains, one smaller one to get through the denser atmosphere, and then one with very big, very high-pitched propellers and lower KV up there to get further when the air density goes lower.
Like what they needed on Mars to fly on Mars.
Similar, yeah.
And
now, speaking,
Adam, how would the RF, or how would the lower density air affect the RF from that side of things?
No appreciable effect. Your line of sight, until you get to the Van Allen belts, going out line of sight up is pretty darn easy. The Van Allen belts are exo-atmospheric, so kind of out of our wheelhouse.
Cool.
Yeah, David Windestar was this, by the way. Grumpy or not wrote in the page. He was the guy with the balloon and the glider. I think it was 120,000 feet or so.
And then the other question I have, 28,000 feet. It's about the altitude of
an airliner.
Airlines fly. Do they fly about between 32 to 38,000 feet, somewhere 32 to 35?
Depends on the path they take. They have like sky highways up there and different altitudes. So yeah, between 28 and 38,000 feet, roughly. Yeah.
But Mount Everest is the elevation, I believe, around 28,000 feet.
A little bit over 10 kilometers.
Yeah. Okay. So again, you would have the same issue if you launch something up there. It would have to be a large propeller going very high KV in order to get it to fly up there.
I mean, that would actually work if you launch there already, because then you can already launch with a specialized propeller that can work in that low dense area, and you have less altitude to gain, and therefore need less battery, less weight, and so on. But the other problem is if you launch at 8,800 meter on top of Mount Everest, you should make sure your batteries are warm when you launch. Otherwise, you won't go anywhere.
There's a lot of problems with launching on Mount Everest. It's like walking on the moon. It's people who go up there get a picture and then come back down the mountain as quickly as possible so they don't freeze to death or run out of oxygen. There's a bunch of dead people who tried to get to the top, to the summit, or come back from the summit and didn't make it, unfortunately. But this is theoretical, which is Mount Everest at 28,000 feet and sea level, which is at 0 feet. What kind of range could we get realistically with the very best link protocol? So, Adam, this is the question I posed. I kind of give you an opportunity to think about this for a few hours and to think about what would be realistic at these two different altitudes. They're just theoretical. I'm assuming you could actually fly an RC plane at 28,000 feet.
Yeah. Well, the answer is it depends on a lot of variables. We know that we've got the technology to control an RC aircraft from the other side of the world, provided you're willing to deal with the latency. And the answer to that is satellite phone. You've got enough bandwidth, to be honest. That's how they fly military UAVs from, they'll fly from the pilots sitting somewhere on a military base in the U.S. and flying, and directing is probably a better way to put it, a UAV that might be flying over Afghanistan or Iraq. Now, in terms of direct link radio control, you got a huge variability. If you're standing on the edge of the beach and you're flying out over the water, you're an absolute worst case, especially at low altitude. Water is horrible to high frequency RF, and the higher the frequency, the worse it gets. So you're really limiting your range there. If it's just direct line of sight through the atmosphere, you've got nothing else around, i.e. you're standing on the top of Mount Everest. You're going out to theoretical minimums of your RF, unless there's any sort of noise in there. 100, 200 kilometers would be theoretically doable with our power levels.
Wow. Is that the 1 watt with like ELRS and 1 watt or 2.4 gigahertz, or ELRS 2 watts, which is not
I would
legal?
say, when I say something like 200 kilometers, I'm thinking 50 hertz ELRS at 2 watts or equivalent, and good atmospheric conditions. Nice and sunny the whole way. You've got no clouds. Again, clouds are filled with water. They actually do very mildly attenuate RF. So these things come down. You can't really predict range. You can predict range in a certain set of conditions. If you give a set of conditions and a particular system, you can do the math and figure out what your range is likely to be. But off the wall, this is why ELRS has that repository of range tests, because there's so many variables in flight, and there's also the opportunity, of course, for indirect control instead of direct control.
Yeah, I think also weather is very important here. I had the experience in the past. I did a flight on the exact same spot with the same plane, just on 2 different days in summer. One day it was a really dry and hot day, and had no problem going out, perfect video, everything was fine. And then another day it was it rained overnight, so all the ground was very moist, and the air was had also a very high moisture level, and I basically had the image at the same remaining quality, my FPV feed at the same remaining quality as I was on the earlier day, just at half the distance. So it can high air moisture can really affect your RF signals, especially video, for example, at higher frequencies. I think 2.4 is also strongly affected, especially because resonance with water molecules and stuff. That's one thing. And regarding the total range and what our ceiling system, I mean, just take as an example, we can reach with a, let's say, doable, reasonable altitude of 100 kilometers with R9 or Crossfire in the 900 megahertz band. And I have seen a Crossfire video with 250 kilometer total range, but in the low update rate 4 Hertz mode, of course. So if you want to go high up, it doesn't really matter. The only thing that matters is your antenna orientation. So you probably want to have a cross antenna, one lengthwise, one ring to ring, and then your ground antenna also pointed up to fly at high altitudes. But the RF links shouldn't be a problem there. And every 2.4 gigahertz link, if you have good antenna placement, can do 10 kilometers or more.
You said said that last sentence again. 10 kilometers with any
with any proper RC link. I mean, it doesn't matter. You can do 10K with Tracer. You can do 10K with Ghost or more. And I even did 11K with an X8R from FrSky with ACCST protocol. So it's doable.
Jeez. Wow. Okay. Adam is looking like completely mesmerized.
No. Yeah, this is something I work like when we say the traditional ones are line of sight, that is using a traditional basic setup. You can do, if you optimize your antennas, most of our stuff, like the traditional stuff, is using 2 dB omnidirectional antennas, which are. But if you go to a higher gain antenna, it's a set of trade-offs. You gain more range, but it becomes much more directional. There's some advanced antenna designs that can offset that. So you can get long range out of systems that should not be able to do it by optimizing the install and optimizing the equipment you're using with that install.
Just for my setup, it's only as an example. I had my AR900 FrSky X8R receiver with the 2 flat PCB antennas in a V shape, and just my X9D with the stock antenna on the radio, and I phase saved at 11.6, I think, kilometers.
Jeez.
Yeah.
So
wow,
if you have a clear RF environment, that's definitely doable. For as another example, the FlySky i6 I had before that, my record with that was 4.5 kilometers.
Wow, fantastic! And then you get even more range with some of the newer Archer receivers, but that kind of does bring one other point up, which is when we have people join the group, what I've seen in the past is we get some people, and you can tell who they are. It's like they're just absolutely turned on by, I got to go as far as possible. I got to send this plane as far as I can possibly fly it. And where I live, if you can't get to your plane within 5 minutes, chances are someone else is going to find it. Right about now. Yeah. So if we were to, what I was going to say is that I don't really want to fly further than I can walk in about 5 minutes, which means usually 1 kilometer, 2 kilometers. I'm in love with the whole flying process and whatever that's about. More so than going out.
Steve.
Huh?
You're a fast walker. 2 kilometers in 5 minutes?
Yeah,
it's not bad.
Yeah. I'm usually running or jumping in my car and driving there as quickly as possible.
Especially
there was one time
McDonald's, right?
There was one time I had this. I'm flying out at this beach area, and I was like, "Oh, I got a perfect signal. Look at that! I got my link quality's great. My video is great. Everything is wonderful." And I realized that if for whatever reason this plane goes down, I'll never see it again. So that's why I decided to turn around. But I mean, there's a lot of us. It was interesting when we mentioned Wesley. There's parts of where he lives in Australia where there's nothing in the interior for literally hundreds of miles at a time. So, at any place in the world where they would look the other way, you think it would be that place. And so, not like high density Southern California. So, but I don't know. Are you guys, Darren, do you really get excited about going as far as you possibly can fly with a radio link?
At the moment, I'm more excited about flying as fast as I can fly, to be honest.
Yeah,
that's what I'm excited about at the moment.
And Mark, I know you've done some long distance flights in the past.
I'm speaking only hypothetical.
Hypothetically, you did this on real flight, right?
Yes, of course, yeah.
Oh yeah, hardware in the loop. I'll fly for miles.
Yeah.
Yeah. So it's to get excited about this it's interesting, but I mean, I think right now there's a variety of radio links that will get you out much further than you can comfortably should legally be flying, could legally be flying. But, you know, unless you're someplace where you're in the middle of nowhere, chances are, we should be thinking more about keeping it closer to home. I hate to be the buzzkill guy, but the reality is now, I mean, Adam was talking about there's a problem in Canada right now where because of long range line of sight.
Yeah, I won't. It's not because of long range flying. It was another issue, but and I can't get into this too much. But right now, a lot of the Model Aeronautics Association Canada fields are shut down, and the organization's working it through with the regulators.
Right. So, I think this could be a larger and larger issue in the future, especially, let's kind of keeping these long distance flights somewhere. My general feeling is this: if you have long distance flights, go somewhere far away from people, get your records, don't talk about it online, do not post videos. It's the last thing we need. So, yeah. Because this is starting to come back and bite us around the world time and time again. Well, it should be it for today. We've had a really great show. Adam, thank you for being here today.
Oh, thank you for having me. It was
fantastic.
Quite an interesting conversation, I think.
Fantastic. Darren, always great to see you.
Yeah, thank you.
Mark, thank you. Stick
Thanks
around,
a lot,
Adam.
Steve.
We're gonna call it a quits for today, but we will be back next month with another edition of Wing Talk. Thanks for joining us, everybody.
Bye.
Bye.
Okay.
All right. Thank you.